All right, in this video, what we're doing, we're actually trying to find the area of these blue circles that are in the triangle. All right, the basis of this question is that we actually have three identical circles. Here they are, and then one bigger circle right there. We do want to find the area that they actually cover with this information. Bear in mind that we have an equilateral triangle with side three. So we're going to use this to solve the problem. You think you know what to do, you could pause the video and solve because I'm about to solve this right now. All right, let's take a look at this. What I'd want to do is I'm going to draw a line from the vertex, any one of the vertex. I'm going to take it here to the center of the circle here. So this is the center. And then I'm going to create a radius from the center to the tangent here. All right, so what we're actually looking at here is a 90 degrees here, right? Because radius actually meet tangent at 90, and we do have a tangent here because it's an inscribed circle. Because it is an equilateral triangle, all of these angles are actually 60 degrees all the way around, okay? And it means then if I'm moving from the center to a vertex, then I would have bisected the 60. So this angle here is actually 30 degrees right here, which would have made this 60 degrees if we check the total interior angle for one triangle. Now with this, I could do a number of things. First, I'm going to find a relationship between the radius of the large circle compared to the smaller circle. So let's take a look. Let us call this side X. Okay, let's call this X. Now, because this side is called X, if I do know my 60-30 triangle, and here it is, the 60-30 special triangle, we do realize that if this is 30, this is 60. The opposite side, if we call this X, then the hypotenuse side is 2 times the opposite side to the 30 degrees. And the adjacent side is simply to take the opposite side and then multiply by the root of 3. This is the general idea that surrounds this. What this means is that this hypotenuse here, I could find that to be 2x overall. All right, so this is 2x for this hypotenuse from the center of the circle to this vertex right here. Now, let me make a radius for the smaller circle here. And it's going to be a 60-30 triangle just the same, right? So it's just a smaller version, and I'm going to call its radius y. So let's take a look here. So I pull out the smaller version, the radius is y. We still have 30 degrees here and 60 degrees here, which means that this hypotenuse is going to be 2y. How are we going to use this? Let's take a look. Remember that this is the center. That means this is y. But the hypotenuse would have started from here and it would have gone here, which is 2y all the way there. All right? So having that, take a look at this. This is x because it is also a radius from the bigger circle. And since everything was 2x, then it simply means that this journey here is x as well. So if you could look, that's how we would have gotten those two x's. Okay. So the relationship here, I could say that x, which is the larger circle radius, is actually 3 times y, which is actually the radius for the smaller circle. So x is equal to 3y. Now I could use this. So this is the relationship that I need. Let's put it up here. X is equal to 3y. We're going to use this soon. Let's keep this there. Now let's go back to the circle. Let's go back to the circle and let's put on some real measurements that we do have. Okay. All right. Let's put on some measurement that we do have. Now remember that because this is coming from the center of the circle and it touched the base here at 90 degrees, it's going to split this into two equal pieces. So this is actually 3/2. Okay. This is still 30 degrees as we know. This is still 60 degrees right here. So what it means then is that I am able to work out the real measurement for this by using the soccer tower, or I could use back my same 60-30 triangle. Let's just say we're using the soccer tower. So it could read that the tangent of 30 degrees is equal to, the tangent of 30 degrees is equal to this radius. Let us say I call that my big R, which is the radius. We could call that R over 3, 2. All right. So that's basically 1.5 if you want to put it like that. So it's actually R over 1.5. So you could look at it like this. So if we multiply both sides by 1.5, if you want, then 1.5 times tangent 30 will give us root 3 over 2. So this R is the radius for the bigger circle is actually the root 3 over 2. Now, that's the radius for the bigger circle. Let me call the radius for the smaller circle R. Remember that the bigger circle is 3 times it. If I take the bigger circle radius, and then if I multiply it by a third, I'm going to get the smaller radius. So it is root 3 over 6. So here it is. I would now have the radius for the small circle. This is root of 3 over 6. And then this one, the bigger one, the radius is actually the root of 3 over 2. I could now find the areas for the shaded part. So large circle, let's go. So the largest circle, remember, the area is pi r squared. So pi is pi still. R is going to be the root of 3 over 2. All I'm going to do is to square that. So I'm actually getting pi. Then I'll have root 3 times root 3 over 2 times 2. So basically this is pi times 3 over 4, right? So we could call this 3/4 pi if we want. So we could represent this as 3 over 4 pi. Let me just write this back quickly. So that's the area for the large circle. Now I'm going to find the area for the small circle and then times it by 3 because it's 3 of them. So let's work with one of them first. So small circle. So one small circle. All right, so the area is the same formula. It is actually pi r squared. But remember though, I'm keeping pi as pi for now. What is r? R is root 3 over 6, and I'm going to square this. So we'll have pi times root 3 times root 3 over 6 times 6. And this is going to give me pi times 3 over 36. And if I break this down, I'm actually going to have 1/12. So basically, I have 1 over 12 pi. And this is for just one of those circles. Now, remember, it's 3 of them. So if you really check this out, this is what you're going to get. If you multiply this by 3, because it's 3 of them now, so we're actually going to have 3 over 12 pi. And this is equal to 1/4 pi. As you could see, 3 circles. So this is for the 3 smaller circles all together. So let's add everything together now. So the area of shaded is equal to 3/4 pi plus 1/4 pi. And that's going to give me 4 over 4 pi, which is just